So what we learned so far? In differential equation, we learned that if y is equal to f of x, a differential equation is an equation including the derivatives of y. A differential equation is an equation containing the derivatives of y. Then for that differential equation, we can define the order. The order of a differential equation is the order of the highest derivative in that equation. Then we talked about linearity. We say that a differential equation is called linear if we can write it this way. If you have some expressions in terms of x multiplied by the derivatives of y, and the operation in between the derivatives and the coefficients that we are multiplied by those derivatives is addition. So we have a linear combination between the derivatives of y and y itself. So the first coefficient times the n derivative of y plus the second coefficient in x times the derivative of y plus the middle terms plus, well, a sub 1x times the derivative of y plus, here you get a sub 0x times y equals to g of x, a function of x, or it might be a constant. We also learned that if a possible function is given to us as a solution of a differential equation, we can verify that is actually a solution by taking the derivative of that function and plug that into the left-hand side, right-hand side of the differential equation and check to see if both sides are equal to each other. Otherwise, we say that, hey, we don't have that function as the solution. So if phi is given to us as a possible solution for a DE, then we can actually verify that. By substituting phi and its derivatives in the left-hand side and right-hand side of the differential equation. If they are equal to each other, we say that, hey, that given function is actually a solution of the differential equation, and make sure to check the domain as well. So now I expect you to ask, well, so far we've been given a possible solution, but how do we actually find the solution ourselves? Well, throughout this term, we're going to come up with different techniques to solve different differential equations. The easiest one is a separable differential equation. So this is our goal, how to solve a differential equation. This is what we're going to answer throughout the term. So to solve a differential equation, that depends on the differential equation that you have. The very first type of differential equations that you're going to see are called separable differential equations. So let us introduce separable differential equations and learn how to solve them. What is the technique? So definition, what is a separable differential equation? Definition of a separable differential equation. A differential equation is called separable if you can separate dy and the function in y and dx and the function in x on both sides of your equation, doing pure algebra. A differential equation is called separable if it is denoted by dy over dx equals to f of x times g of y. So take a look at this. On the left-hand side, I have the derivative of y with respect to x. On the other side, I have two functions. They are multiplied together. The operation is multiplication, so be careful here. We don't see any addition. We don't see any subtraction. We see multiplication. Is multiplication. Then we can separate dy and the function in y, dx and the function in x into different sides of the equation. So this is actually how we solve a separable differential equation. How to solve a separable differential equation. So if you have a separable differential equation, you can move forward and follow the steps. Step 1, separate dx and f of x from dy and gy. How do we separate them? We write them on different sides of the equation. So take a look at this. Here I have dy over dx, f of x, gy. So what I'm going to do, I'm going to multiply both sides by dx. I get dy equals to f of x dx gy. Now I'm going to divide everything by gy, and then I have dy over gy equals to f of x dx. So we separated dy gy from f of x dx, or you separated f of x dx from dy gy. You have all y's on one side, all x's on the other side. In the second step, in step 2, take the integral of both sides. Okay, by taking the integral of both sides and going back to elementary calculus, we solve this separable differential equation. So on the left-hand side, you get the integral of dy over gy equals to the integral of f of x dx. Don't forget about the constant of integration at the end. Very well. Let's cover one example to feel more comfortable about what are we going to do here. example. This example says, well, check to see if the following equations are separable or not. Which ones are separable? So read the question carefully. I'm just asking you, check to see which ones are separable. I'm not asking you to solve them. Just check which ones are separable. The first one given to us is, well, dy over dx is equal to x squared. Is this guy separable? So remember that we say that a differential equation is separable if we can separate x's from y's. So multiply both sides by dx. Pure algebra. This is just algebra. Okay, what do we see? You see we have dy equals to x squared dx. Did I separate this differential equation? Yes, of course. Well, on the left-hand side, we only have dy. The function that is multiplied by dy is just 1. So dy is separated from x dx. All y's, and this is all x's. dx, x squared, dy, and the function 1. So this is separable. This is a separable DE. What about the second one? Number 2, it says, well, you have dy over dx, which is equal to x squared divided by 1 minus y squared. Well, is this separable? What we can do, we can get rid of the denominators by multiplying both sides by dx and also 1 minus y squared. So multiply both sides by dx and also 1 minus y squared. Again, this is just pure algebra. There is nothing calculus about it. So if you multiply both sides by dx, you get dy equals to x squared dx divided by 1 minus y squared. If you multiply both sides by 1 minus y squared, you get 1 minus y squared dy equals to x squared dx. Well, have I separated function of y dy from function of x dx? Or have I separated function of x dx from function of y dy? This is obvious. All y's are on one side, all x's are on the other side. So we have a separable differential equation. Function of y times dy, function of x times dx. This is a separable DE. Very well. Example number 3. Take a look at this guy here. Dy over dx is given to us as y squared x times e to 3x plus 4y. Well, okay. I'm looking at this expression on the right-hand side. I don't have any problem with y squared. I don't have any problem with x, but here on the exponent, your x and y's are connected together. They are attached together by addition. Okay. Before make any decision about this differential equation being separable, non-separable, remember from algebra that we can separate these two. So let's write this quick note for you here. If you have a to power n plus m, you can separate this as an times am. So e to the power n plus m can be written as e to the n times e to the n. We can separate these two. So by algebra, just pure algebra, we can write this guy this way. So on the left-hand side, we have dy over dx. On the right-hand side, we have y squared x e to 3x times e to 4y. So you can see that all of these terms, all of these functions are just multiplied together. So can I separate these? Let's try. First, get rid of the denominator, dx. Multiply everything by dx. Multiply both sides by dx. Get rid of dx. So what you're going to see, you're going to see dy equals to. So here you have, let's see, y squared e to 4y x e to 3x times dx. All right. Well, somehow I need to get rid of the function in y. I have y squared e to 4y. Somehow I want to take this and bring it to the left-hand side. From algebra, divide everything by y squared e to power 4y. Now, divide them by y squared e to 4y. Well, what do you get? Dy divided by y squared e to 4y is going to be dy over y squared e to 4y equals to. Well, on the other side, when you divide by y squared e to 4y, then you get rid of this. You get x e to 3x dx. So have you separated this differential equation? The original differential equation was looking a little bit off. It has exponent 3x plus 4y, but we knew algebra. We are going to get help from what we learned before. So we separated the exponent. Then we try to check to see if we have a separable differential equation or not. So as you can see, all of your y's are on one side, all of your x's are on the other side. So what's the meaning of that? It means that you have a separable differential equation. All y's, all x's. On the left-hand side, you see dy and all expressions, functions in y. And on the right-hand side, you see dx and all expressions, functions in x. So this is separable. So what's the meaning of that? In all of these cases, you have a separable differential equation. So if I give you a quiz, a homework, or a midterm question, and I ask you, hey, check to see if these are separable, then move forward and solve them. You can take the integral of both hand sides and start solving this differential equation and find the family of solutions for this differential equation. Well, give us an example of non-separable differential equation. So let's take a look at number 4. Number 4. For number 4, we have this. We have dy over dx, which is equal to y plus sine of x. y plus sine of x. So, is this separable? Remember the definition of a separable differential equation. Separable differential equation has the form dy over dx equals to f of x times g of y. Here you need to see the multiplication between two expressions, two functions that you have on the right-hand side. Okay, I have my function in y, I have my function in x, but the operation in between is not multiplication. The operation that we see must be multiplication. Here you have addition. Multiplication. So you're going to say that, well, since we cannot separate y plus sine of x, so it is not a separable differential equation. I expect you to ask, well, I know it's not separable, but can I eventually solve these types of problems? We're going to go through different techniques when we have non-separable differential equations. So don't worry if you don't know how to solve it right now, that's absolutely fine. In the later sections, we're going to talk about methods of solving non-separable differential equation. So this is not separable differential equations. It means that we cannot use the method of solving separable differential equation for this differential equation.